Deep within the hearts of dead stars, a substance may exist that could rewrite the laws of biology and physics. It is called strange matter, and its basic units, strangelets, are the ultimate cosmic predators. If a single strangelet touched Earth, it would begin a chain reaction that instantly consumes everything nearby. Normal matter is made of atoms, which contain protons and neutrons built from up and down quarks. However, physicists theorize a third type, the strange quark. When up, down, and strange quarks combine in perfect balance, they create strange matter, a substance far more stable than anything we currently know today. In physics, everything seeks the lowest energy state to remain stable. Normal atoms are stable, but some scientists believe strange matter is the true, lowest energy state of the universe. If this is true, normal matter is actually unstable and just waiting for a specific trigger to transform into something else. A strangelet acts like a subatomic virus. The moment it touches a normal nucleus, it forces the ordinary quarks to rearrange into strange quarks. This releases massive energy and creates more strange matter, which then goes on to infect neighboring atoms. It is a subatomic plague that cannot be easily stopped. Where would these monsters come from? The most likely birthplaces are neutron stars, the collapsed cores of giant suns. The pressure inside these stars is so intense that protons and neutrons may dissolve into a quark soup. If the conditions are right, this soup transforms into stable and lethal strange matter. Some astronomers believe that entire strange stars exist in deep space. These objects would look like normal neutron stars, but would be made entirely of strangelets. If two strange stars collide, they could spray trillions of tiny strangelets across the galaxy, drifting through the dark void like invisible and silent hunters. If a drifting strangelet ever collided with Earth, the results would be instantaneous and catastrophic. It wouldn't just cause an explosion, it would start converting our planet's atoms into strange matter. Slowly but surely, the entire Earth would shrink into a dense, hot ball of strange matter only meters wide. Could this have happened before? Some scientists have searched the moon's surface for signs of strangelet impacts. Because the moon has no atmosphere and has been exposed for billions of years, it should theoretically act as a net for cosmic strangelets. Yet, so far, our lunar samples remain perfectly normal stones. When the Large Hadron Collider first turned on, some critics feared it might accidentally create a stable strangelet. They worried that high-energy particle collisions could mimic the conditions of a neutron star. However, CERN physicists calculated the risks and concluded that creating a stable, planet-eating strangelet was practically impossible in labs. Nature has been performing high-energy experiments for billions of years. Cosmic rays with far more power than any human machine constantly strike Earth's atmosphere and the Sun. Since the Sun and planets are still here, it proves that strangelets are either extremely rare or impossible to create through simple collisions. A strangelet's danger depends entirely on its size and charge. Small strangelets might be unstable and decay instantly, posing no threat to us. However, if a strangelet reaches a critical mass, it becomes perfectly stable and starts its unstoppable conversion process. Finding that exact limit is a major goal today. Could strangelets explain certain mysterious signals from space? Some ultra-bright, short-lived bursts of radiation don't fit the patterns of traditional supernovas. Some theorists suggest these are strangelet novas, occurring when a neutron star suddenly converts its entire core into strange matter, releasing a massive wave of pure and concentrated energy. NASA's NICER mission on the International Space Station is currently studying the size and mass of neutron stars with extreme precision. If a star is found to be smaller and denser than physics allows, it could be the first definitive proof that strange matter exists. We are looking for cosmic monsters. Some physicists propose a wild idea. Could strangelets actually be dark matter? Since strange matter is incredibly dense and doesn't emit light, it fits some descriptions of the mysterious substance holding galaxies together. If dark matter is strange matter, the universe is much more dangerous than we ever dared to imagine. Strange matter is predicted to be incredibly hot, reaching temperatures of millions of degrees during its formation. However, once it stabilizes, it might become cold and inert. This temperature shift makes it very difficult for our current telescopes to distinguish a strange star from a standard, cooling neutron star in space. Why hasn't the whole universe already turned into strange matter? There is likely a massive energy barrier that prevents normal quarks from shifting into strange ones. It requires extreme pressure or heat to jump this wall. Without that initial spark, our normal and comfortable world remains safe from the strangelet's touch. If the Big Bang was hot and dense enough, it might have created primordial strangelets at the very beginning of time. These ancient particles could still be drifting between galaxies, leftovers from the birth of the universe. They would be the oldest and most dangerous travelers in the history of the cosmos. How do you find something that looks like an ordinary particle but weighs as much as an asteroid? Scientists are building massive underground detectors to look for heavy tracks in our atmosphere. A strangelet passing through Earth would leave a unique seismic signature, vibrating the entire planet like a giant hit bell. If the strange matter hypothesis is correct, the long-term fate of the universe could be a total transformation. Over trillions of years, every star and planet might eventually encounter a strangelet. The universe would end not in fire or ice, but as a collection of cold, dense, and strange remnants. Strangelets remain a theoretical nightmare, a reminder of how little we truly know about the subatomic world. Is the universe's true state hidden in a single, deadly particle? Like this video, subscribe to World of Mysteries, and let us know, do you think strange matter is the ultimate end of everything?